See, this kind of question will definitely come in your exam. In all these kind of waveform are almost similar type. First of all, we have to see that what we need to calculate. In all the cases, they can ask you the RMS value, they can ask you the average value, they can ask you the form factor, and they can ask you the peak factor. Okay, so in one single lecture, I'll tell you how to solve all these kinds of waveform. First of all, if they ask you the average value, then we need to calculate the average current, right? So formula for that would be, it varies from alpha 1 to alpha 2 I dt divided by the base length. I'll tell you what is base length. And similarly, we are having another formula for IRMS. IRMS is root mean square, so we'll take it a root. Then again, limit vary from alpha 1 to alpha 2. Then in that case, we'll see I square dt divided by the base length. Okay, divided by the base length. So see, how can we get it? First of all, we have to see what is alpha 1 and what is alpha 2. So solving for these kind of question, we'll have to follow certain steps. Step number 1, we have to see whether it's in symmetry, okay, or it would be in asymmetry. The waveform is in symmetry form or in asymmetry form. Like suppose in this case, this is in symmetry form, right? This is also in the symmetry form, right? This is also in the symmetry form. But if you see this waveform, then it is not in the symmetry form. Why? Because as you can see, from the time 1 to 2, there is no output. Got it? So symmetrical waveform have a single pattern and asymmetrical waveform have to follow different pattern. Got it? So as you can see that it is varying. Like we don't take it for the full structure, we'll see it for this one only. Okay, we'll take only this waveform, then we'll get it know how can we get it. Now as you can see that this vary from 0 to 1, right? So its alpha 1 and alpha 2 value is 0 to 1. Got it? So I'm writing down here only what is its alpha 1, 0, and what is its alpha 2, 1. Okay. Now in the next case we should know what is base length. Base length again, that is it vary from 0 to 1. So base length would be equal to how much? That is 1 minus 0. Got it? If they said 2, then in that case we'll take it as 2 minus 0. Okay. Now see, in every case it would be same. Alpha 1 is 0, alpha 2 is 1. Alpha 1 is 0, alpha 2 is 1, and base length would be 1 minus 0. Correct? But again, as I say, in the asymmetry waveform, it would be different. So in this case, alpha 1 is again, it start from 0, so we'll take it as 0. Alpha 2, it ends up to 1, so it will be 1. Now the base length is how much? In this case, the base length is equal to 2 minus 0. Why 2 minus 0? Because as it is asymmetrical, so we'll take the output of the complete waveform, means half positive and half negative. Okay, so as you can see, in this case we take the output of the first one because it's same, it's symmetry. But in this case we'll take the output of the complete waveform, this one. That's why its base length is 2 minus 0. Got it? So this value may vary, it may vary from question to question. Understood? Now in the next case we should know I is the current, right? So how can we get I? As you know that tan theta is how much? Perpendicular over base, correct? Perpendicular is how much? Perpendicular is this one, correct? Correct. And perpendicular in this case is current, so we can say current. And base is how much? This one. And base is how much in this case? That is time. So can we say that tan theta is equal to I by t, right? Here I is how much? That is how much it goes up to maximum 5 ampere, and t is how much? That is 1 second, correct? So if we'll see only this portion, that I by t is equal to 5 by 1, can we get the value of I? I is equal to how much? That is 5t. Yes or no? So I is equal to how much? 5t. So now we got the all the values. We got the base length, we got alpha 1, we got alpha 2, and we got I. We just now need to substitute the value. Correct? So for the first case, first waveform, if we want to calculate I average, that vary from 0 to 1. I is how much? We just calculated. That is 5t. That is same for each and every case, right? Because tan theta is I by t and I is 5 in each case. This one also it is 5 ampere, and on the x-axis we'll get it as time. Okay, so I is how much? That is 5t dt divided by the base length. Base length is how much? 1 minus 0. Correct? If we'll solve it, then how what we'll get? 5 is the constant. We can take it outside. Then t square. If we'll integrate the t, then it would be t square by 2. Correct? Divided by 1. Now we can, if we substitute t is equal to 1, because as you can see that time at 1 will measure, so that would be how much? 2.5 ampere. Got it? Now if we want to calculate IRMS, again the formula for the IRMS is this one. Its limit vary from alpha 1 to alpha 2, that is 0 to 1 I square dt. I square dt means 5t square, that would be 25t square dt divided by the base length. Base length is how much? 1 minus 0. If we'll further solve it, then it would be 25t cube divided by t. If I'll put again in the limits that 0 to 1, then we'll get it as 5 by root 3 ampere. Got it? So if we get the average value and RMS value, can we get the form factor? Form factor formula is RMS by average. And can we get the peak factor? Peak factor is maximum by RMS. Correct? So always you will get the same value of form factor 1.11, peak factor 1.414 by substituting this value. If you'll get any different value, then it means that is your answer is wrong. Okay?